Tonight is January the 4th, 2022, and what I'm going to show you guys tonight that I have built two of, but I'm going to build a third one just because I want to build something, and it's an antenna tuner. It's the one over here. It's the one called the Ultimate Transmatch, and there's a schematic for it right there. It's got a split stator capacitor right there on the left. This one right here. Then it's got a variable inductor. And then it's got a series capacitor for the output. So everything in it has to be floating. Meaning the capacitors have to be mounted on standoffs. And then you can wire it for a long wire or whatever, but I don't use long wires. I hear they're pretty good, I just never have used one. But anyway, we're going to build one of these. I've had these little inductors right here for a while, a couple of them. Got two of them at the same time, and they are just beautiful. I'm going to build something with this one. See, there's even the little coupler. Couples to the front. Okay, these things are just beautiful. Probably good for, you know, a few hundred watts, not multi-kilowatt stuff. But anyway, the split stator capacitor is this guy right here. The split stator means that, you know, half of it is the same, and then this section is isolated from that section. These two are independent, and this one is common. And the way it's wired up is we put the actually we put the signal in to the common when we put it into the casing, and we put one of these fixed ones, one of these sections to ground, and then the other one we put over to the inductor, which goes to ground, and then we put it through this series capacitor to output. Now I built some big ones using vacuum capacitors, but that's not necessary for this because they're good for more than just matching the output of your rig to an antenna. They're also good for matching the input of your rig to a driver. For example, if you're a home brewer like I am, the input impedance of your amplifier may not be 50 plus J0. It may not be the perfect match. And if you're driving it with a solid state rig, then a solid state rig may not be very happy at all. It may not load up. May just kick offline or whatever. So you can put this between the transceiver, the exciter, whatever you want to call it, and the input of your amplifier. And it works great. I use it right now on my 833A amp. But anyway, I'm going to get busy. What I'm going to do though, I'm debating on whether to take these three pieces off right here and put ceramic insulators here, or to add ceramic insulators in series with it. I think I'll take them off. So it's going to be mounted like this. It's going to be mounted to the front of it like that. And then the shaft will come out right here in the front, right there in the center. So if I mount it like that, well, actually I can mount it directly like that because they're all insulated. This thing right here, the coil itself has to be insulated from the chassis, but actually it already is. So I don't actually even need to add insulators to that. I can mount it directly. Okay, well, that helped, didn't it? I'm glad I'm talking about it. I'll just mount this guy right here. Okay, this one right here is going to mount in there, but since it's floating, I've got to cut this shaft off, and then it'll mount in there. And I decided what to do with it is I'm going to drill and tap 4 holes right here and put it on some 1-inch ceramic standoffs so that it'll actually be in there mounted like that right above the chassis, because this piece right here has to be insulated. So if I cut this off, and then I'll put an insulated shaft coupler here, and then the shaft will stick out and it'll be mounted right here. And the third one is this one. So this actually should be a fairly easy project. I'll put 2 standoffs right there, 2 ceramic standoffs, and it'll be mounted right there up just a little bit, coming through the chassis. That's its output capacitor. The coil is mounted right here. And then this guy right here, I can't get it in there because that shaft's too long right now, but it'll be standing up about that height right there. And that should work. I don't exactly like the way I'm having to build this. This is a little flimsy. So probably what I'm going to have to do is, I know that didn't go on there exactly right, but that's okay. Yeah. Anyway, you know what I'm trying to do. I'll probably have to mount some, drill and tap some screws right there in the front to make the top and the front rigid. And then I'll put the input and output. I'll use SO239s. End connectors are great, but you know what? You nearly always need an adapter. You know what I mean? Okay, so that's the general setup. I'll have to show you some of my bigger ones too that I've built, and I actually, like I say, use one of these to tune the input of my 833. What I do is I turn it on, load it up, whatever, make sure that the amplifier is fairly tuned up, and then I use like a Rig Expert or whatever you want to use to adjust the antenna tuner, the ATU, so that I got 50 ohms with no reactance, and works great. Okay, well, let's get started. Okay, well, I've made some real progress. I got the coil mounted, the output capacitor mounted. Still got to drill a hole right there. It's always a challenge to get this stuff lined up really nice. I've drilled and tapped the insulators on the bottom of this thing so that it will sit in there like that. I actually may end up having to shorten this a little bit more because I'm not sure that you know, something like this is going to fit in there. It needs to be, it has to be insulated. So I'm probably going to have to cut that one off again, just a little bit. I use 632 taps. Got a lot of little taps here. I imagine you guys that build do the same thing. Got to have all this stuff. All the sizes, especially 6 and 832, unless you do metric, which I try not to. And you know, a lifetime of whatever junk parts, which is what it takes to build things. Anyway, I'll be back tomorrow in about 5 seconds or so. Okay, well, let's keep moving forward. I'll show you how far I've gotten at the moment. Got all of the 3 major components mounted. The input capacitor, the coil, and the output capacitor. It only takes like 5 wires to hook this thing up. This will be the output right here. Wire comes from either side of the capacitor. I'm going to put there a little short wire there. The input, which I got to mount over here, will go to the casing of this capacitor right here. And one side, you know, these are, as I mentioned, these are 2 different capacitors in here. This one is the common part. It's a split stator capacitor. One side will go to ground, doesn't matter which side, and the other side will come over to the top of this coil, and then a wire comes over to here, and this side grounds. So I'll put a common ground between here and one of these, probably right there, maybe even to the connector. Haven't decided yet. But I wanted to show you some things. It seems like for the newcomer, people have not built before, you need tools like this. This is they're known as Greenlee. That's the brand name. I think there's other brands. These things come in a bajillion different sizes. And I've had some of these things for, I'm sure, 50 years. You drill a pilot hole, See the two pieces right here? And then you put this in there, and you put this on the back of it. And when you start screwing them all together, it's actually quite sharp and very, very hard. And then you take a, I'll make sure I get all this on the camera, and I'm liable to be doing something thinking the camera's pointed at it and not have any idea. And then you just start turning this guy. I know a bunch of you guys and gals out there know this, but everybody may not. And then I got the perfect hole. It's exactly the right size. Some time ago, it was pointed out that the measuring device I use right here is called a caliper and not a micrometer. And I use this thing religiously. Like, measure your connector. Look at there, it's 39/64. But to make it just a little bit bigger, and look, it turns into 5/8. See that? And then you, of course, it's got written on there 5/8. But you always want to check, because if you drill it, see there? There's 5/8. Okay? So you don't make like, oh no, mistakes. Well, here's something. I'm gonna take the camera off here. I gotta show you a couple of things. That's a little bit unique about this, and I don't know, maybe I'm beginning to understand a little bit how even building something what I think is as simple as this can be quite a challenge. Well, see, I use these bushings right here. This is a good idea, and I have lots of that kind of stuff. Here's some of the, look how long these things are. See how long that one is? This length right here from finger to thumb. And then others are a lot shorter. Well, I didn't realize it, but the length of every one of these things was actually pretty critical. And especially this one right here. Because everything in here is floating. That's why they're up on those ceramic insulators. This one right here is floating because this is insulated material. See, this one's floating up on two capacitors. It's a little flimsier than I'd like it to be, but that's the way it is. And then you have to use these shaft couplers that are insulated, because all of this stuff is hot. So you need buckets. You need a lifetime supply of this kind of stuff. I was just thinking, if I was trying to build this thing and order parts one at a time or whatever off of eBay, it's almost impossible. And this is just a small fraction of this type of hardware I have. I have another big box of it up in the attic, 2 or 3 probably. So you got to have this, but this is a lifetime collection of all this junk. See, I'm going to, this knob is just there for testing. I'm not going to put that one there. And then, you know, and then you have to just make your own personal choices. Would you mount the connector like that, which is what I'm going to do, or you might actually find it, your preference might be that. Work just as good. Actually, that's a little neater, isn't it? There are several things, little things like that I was just going to point out. And then, of course, if you're a new builder, some of the things you need a vacuum cleaner. Because you're always getting, see, I've got to vacuum this up. I'm not going to start the vacuum cleaner so you can hear it run. You know what a vacuum cleaner sounds like. See, this is what that little piece of metal looks like once you punch it out. It's actually still inside here. So I got to take it out before I put it back in the box, put it back in the cabinet. Like I say, I know I've had some of these things for 50 years, since I was a kid. I've had them longer than that. So it's coming along very good. I'm debating on whether to mechanically disassemble it again, since I've got all of the parts. That'd be like a kit. I could disassemble it, lay it out in practically a kit form, and paint it and put it back together. I thought, well, should I make it like wrinkled gray? Oh yeah, well, let's make it wrinkled gray. Let's always make it look like something out of a Cold War underground nuclear silo. Or should I make like this, you know, like flaming orange, and this one blue or green. No, I actually thought about making it some very strange colors just for something to do. I don't know. But it's coming along. I don't want to bore you with too many details, but it, like I say, for the new builders, you may not be aware of all of the little intricacies that and techniques that a person might be using to build equipment. It's nice to have a deburring tool like this. This thing you put, after you drill a hole, you put it in there, and that takes the burrs off of it. And for small holes, I don't have one right now to show you, but I've got to drill 4 holes right here. You know, I'm going to put this thing up there, whether I mount it inside or out. Mark those 4 holes. After you drill them, you can use a larger bit like this on those small holes to deburr. It's kind of hard to get it to the back, so you'll have to figure out a different way for that. But if you can get to the front of the hole, you can deburr it with like a 1/2 inch bit. That's a nice tool to have. As you can see, I even have I've had this one for many years. This is an old one, but a good one. But so I even put a rubber handle on it. So that is some things. Got to have a lot of parts. I won't get into all the parts. Seems like I had something over here I wanted to show you, but now I can't remember. Here's a schematic of it again. This is what we're building right there. And these work good. Okay? For what it's worth. Oops, excuse me. Okay, well, let me get back to work. Here's my buddy right here that I showed you the other night. He's doing very well. All of you out there are so very kind. You don't know how I appreciate it. He eats, he takes his medicine, he feels good, he purrs when I scratch his ears. And we're doing just fine right now. Thank you so much. I'll be back when I get a bit more built. Okay, I want to show you something while it's on my mind before I forget. When I put this back together, see how when this part of the capacitor is completely open? Well, you can see here that it does not hit the aluminum. But I was told by one of my friends about this, and this is some cool stuff. This is mica that you can order off of eBay. It's very inexpensive. I think you get at least 4 at a time. And just because I'm a little bit neurotic, I'm going to mount that right here on the roof of it. Can you see what I'm doing? Before I put it over the top of it to insulate it. So anyway, I just thought that this was some of the coolest stuff. I use this also nowadays. See, here's a piece I've been cutting up. You can cut it up with scissors, and you can, well, I don't know, you can just use it for so many things. You can mount. I like to build high voltage power supplies, you know, 5,000 volt power supplies or something I do. So you can mount capacitors on it. Because if you mount those standard PC board type ones with the axial, no, the radial type capacitors, you know, with the 2 points sticking out. Well, you can't mount them directly to the chassis, especially at high voltage, because it'll arc through. The bottom of it will arc. Let me see if I can find it very quickly without kicking the camera or anything too hard. Yeah, these type of capacitors, you've seen them. It's not a good idea to mount this. This one is a little better because at least this is covering, but not all of them. Some of them are, it's got a very thin piece of insulating material there. And I use goop. I don't recommend using the higher strength adhesive, but if you use goop, you put just a little bit there and you can stick it to the chassis if the negative side of the case is at ground. But if it's not, if you're going to put a bunch of them in series, you mount them just a little bit at a time on a board like this. And this is mica. I mean, I don't know what its insulating properties is, but it's probably good to, you know, 20,000 volts or so. Just thought I'd throw that in before I forget it. Okay, before I quit tonight, I've actually got it wired it took, I counted 5 wires. It actually took 1, 2, 3, 4, 5. It took 6 wires to put it together. I've got a dummy load on the output. I've got my little rig expert looking at the input. Now I know I'm loading it into the perfect 50 ohm dummy load for HF. I understand that. But I want to show you how I do it, and it works very well for me. We're watching SWR right here, which we got 46 and 49 right there. You can think you can see everything pretty clear. The way that I have learned that it seems to work quite well for me is I set the capacitors at half capacity. See, I opened that one halfway up. See, that's closed halfway. And then I'm going to do the same for this one, halfway. This may not be the ARRL prescribed way, and I don't care. I'm going to do it. I've been doing it this way, and it works. Okay, and then I start, the inductor is completely shorted now. It's at 0. Now, watching the SWR over here, look, it's at infinity too, right? I'm going to start raising the inductor. I'm going to put some inductance in it. And in a minute, look at that, it went down from infinity to 37, 20, 17, 12, 6, 4.3, 3. 2.9, 2.8, 2.7, 6, 5, 4, 4, and okay, it went up there. 2.4 seems to be as low as it goes. And then you start with the 2 capacitors. It doesn't matter which. I'm going to start with the input capacitor. Let's see if I can get it any lower. Not a whole lot. Got it down to 2.1. I'll start with the output capacitor. Whoa, look at that. And then you just go back and forth, tweaking them, including the inductor. Don't forget the inductor. We haven't like written him off yet. 1.04, you know, I mean, it's here. We're here. Fighting anything below 1.04 is just kind of ridiculous because our instruments can't. Our instruments are just not that precision. But I bet we're going to get it to, I bet we're going to actually get it to, there you go, 1.02. Let's see if we can get there. Let's touch the inductor again. It's going to be the most sensitive. No, we better leave him alone, and let's touch this capacitor. Well, I hope you see there. I mean, when you get your SWR down to numbers like that, you have won the lottery. So we can see that the little circuit works. Actually, it was trying to go to 101, wasn't it? There it is. Oh, look at that 101. No, we want to go. Okay, we can't get there, but that's it. That's, like I say, I set them to half and half, and then I turn the inductor until it drops really low. And you can use this for loading your transmitter into the antenna, or you can use it for loading your transmitter into an amplifier, if you don't have a tuned input. Even if you do have a tuned input, sure it works, doesn't it? Pretty amazing. Well, of course, this is not going to be it right here. I'm going to dress it up and put different knobs on it and make it pretty. But it's basically that simple if you got all the right parts to play with. Be back in a minute. Sorry, I forgot one thing. These things come to me oftentimes after I've made a video, and I go, darn, I wish I'd remembered that. A good friend of mine down in Australia has reminded me, he was telling me what he did. I put my soldering iron right here, because it's real easy to forget, and I don't leave it on all night, all the time. But I built a little timer right here. You got this stuff at Lowe's or Home Depot or whatever your preference is, and it's set for an hour. It just plugs into the wall outlet, and then I plug the soldering iron into it. And I turn it on, of course, turn the soldering iron on, and then I set it for whatever time. I usually set it for an hour. And this thing right over here, I've got it all cranked out of shape right now, but anyway, it lays down there nicely. There you go. And that way, if you forget, you get distracted or whatever, it turns your soldering iron off for you. And while you're not wasting an enormous amount of energy with a 40-watt soldering iron, you are creating some sort of a potential hazard. So I just thought I'd throw that in while it was on my mind. Stay safe. That's what you got to do. You can hear it ticking. Okay, now that it is functionally built and works, let's see what kind of frequency range it has, and let's see what kind of SWR it can resolve. What I've built here is our little fake antenna. I got a 100 ohm resistor and a 100 picofarad capacitor. So in a perfect world, this would be in rectangular coordinates, it was just be 100 minus J, whatever the impedance, whatever the reactance value rather of this capacitor at what we said, 14.2234. That's where it happened to be set, 14.234 megahertz. If we do the math, 1 over 2 pi FC, we get 111.81 ohms. Call it 112 ohms. Hope you can see that without all the glare. 112. Okay, so this should be 100 minus 112. The impedance of it. Let's see what our little rig expert says it is. Let's see. Cancel. I'm going to put this in cancel and put it on all parameters. Okay, it says that the R is 80 ohms. So it's 80 ohms. It's not 100 ohms anymore. It's 80 ohms at 14 megahertz. And our the reactance of our capacitor is minus 100 ohms. We calculated 112 minus 112 ohms. So it's we're going to use these numbers instead of what instead of 100 minus 112. So it's 80 minus 100. If we wrote that down as Z equals R plus JX, it would be Z equals 80 minus 100. I'm going to round that up, of course. Okay, so we need to make a note of that. And then 80 minus 100. I'll just try to remember. We're going to put it on the output of the our tuner, and we'll put this on the input. And we'll see it's already, just because of the way we got it set, it's already changed it significantly, but we don't care about that. Let's go back to our little SWR meter, and it says that SWR is 15. Well, actually, we need to do this first. Let's see what we know that it's 80 minus 100 in rectangular coordinates, but it says that our SWR right now is 4.5. Let's see if we can resolve an SWR of 4.5. This is our fake antenna. See what I mean? Okay. So we'll put our test antenna on here. And of course this is on the 20 meter band. And then we'll put our meter there where it can be seen. I think you can see that. And the way that I've learned to do these things is I set the capacitors at half capacity, and then I start turning the coil. Right now I've got the coil completely shorted out. There's no coil in it at all. And I start increasing the coil, watching the SWR, see it dropping dramatically. Get it as low as it'll go. 3, 2.4, 3, 2, 1, 1.8, 1.7. Actually, wow, it's going down there pretty good, isn't it? Just with the capacitors at half. Let's see, there's 18, 19, 20, 18, there's 17. I saw 17 in there. Okay, about 18, and then we start turning the capacitors. You can absolutely get it to 1.00 if you 1.06. I mean, do we really need to go any further than that? There you go, 1.01. So we can resolve a 4.5 to 1 SWR in the 20 meter band, 14.234 megahertz to be exact. But so we know it works at 20. We'll have to go up to 10 meters. It'll do the same thing up there. I don't want to bore you with endless measurements here. It works very, very good. You can resolve all of these SWR, these poor SWR measurements well up into 10 meters, but it won't work below 40 meters. It'll do exactly the same thing on 40, but it won't work at 80 meters because this coil, which is like 5.5 microhenries, is not large enough. Because you can set the capacitors, if you can fully mesh them, and you can put full all of the inductance in there, and it won't work on 80 meters, but it'll work on 40 meters up, which is okay with me. I got some big ones in if I need to go to 80 meters. Mostly I wanted it for 20. So that's one way you can measure all this. I don't know if you've I don't want to get too weird here, but if you look at these all parameters, they're actually pretty interesting. Let's see, make it run. This number right here, see that those vertical line, that means the absolute value of Z is 25 ohms. That 25 is derived by, it's the square root of R squared plus X squared. Square R and then square X, then add them together and take the square root, and you'll get that number right there, to 25. Just for a little tidbit. Anyway, so it works quite well right there, and that's one way to test it. You can do that if you've got, you know, some instruments to play with. You can do that with your with any tuner you have. Okay, well, I went ahead and finished it up, but I want to try it out. I want to test it. Here's what it looks like. I labeled it so I got a full mesh of the split stator capacitor, full mesh over here of the output capacitor, and then a little rotary thing here on the, it's kind of hard to do this, on the coil. The back of it, well, at the moment I've just got some BNC type adapters on it, and there's a ground connection. I always believe in ground connections. And I've already painted it. It's already getting chipped, so I don't know. Getting paint to stick to this aluminum is sometimes a challenge. Okay, so that's the way it's going to be. Now what we're going to be testing it with is this little rig expert. I think people, just about everybody's kind of familiar with that. I'm going to put it in as an input, and then we'll put this funny little antenna, you know, my 4-to-1 SWR 4-to-1 type antenna on the output, and we'll be measuring it. And then what we're going to be staring at pretty much the whole time is, sorry for the bumping around. I hope I can do this gracefully. We're going to be staring at, I'll get there, this spectrum analyzer right here. Making some real measurements. There we go. Not exactly square on, but hopefully close enough. I don't know if you'll be able to read all those things or not. Actually, oftentimes you can read things better. So what we got to do, you got to make a bunch of measurements. If you enjoy this kind of stuff, hang around. You don't enjoy the tediousness of all these measurements, then this could be pretty boring. What I've got right now is I've got this thing straight into it. We're just looking at the output right here. And we're going to look at the fundamental, which I happen to have set at 14.2, what is it? 254. So look here, frequency, 14.254 megahertz. There's what that's what it looks like. We'll look at peak. It says that our output up here is about minus 6.5 dB. 14.254. 14.254 is minus 6.5. Minus 6.5. I've got a 20 dB attenuator on it here. You got to be very careful with your spectrum analyzer. You don't want to burn the front end. I've got a 20 dB attenuator and a DC block. So it's really 20 dB higher than that. That's what's actually coming out of this rig expert, but we don't really care. Spectrum analyzers have a lot of gain in them. Okay, now we'll look at its second harmonic, which is going to be at 28.508. 28.508. I have to write all this down. Frequency 28.508 megahertz, and then we do peak. And it says it's down right here. It's where we're reading minus 40. Call it minus 43. Minus 43 dB. And we'll look at its third harmonic, which is 42.762. 42.762 megahertz. So its peak is, see, it's down at 16.768, 16.6, whatever. Okay. 16.6. At its third harmonic, 42.762. 42.762. We'll look at all this data here in a second. Okay, now we're going to go back down here and hook this thing up. You can see Mr. Pito laying over there. He's all comfy. He's got a he's got a heating pad there he loves to sleep on. He's doing great. He's doing great. And this is the output. We'll put this into the output here. I better look, or I'll get the out my end messed up. Yeah, that's the output. Okay. And then the input. Really, what I'm trying to show you here is what the ARRL handbook tells us to do. And without moving the camera around a whole lot, what they tell you to do is to make the capacitors, start out with the capacitors maximum, fully meshed. And then we start turning the knobs. It says start with the inductor and turn the inductor until you get it as low as it'll go. See, that's zero inductance. Now I'm starting to turn it. You can see it going down. Goes down to about 3.5. See, it starts back up. That's as low as it'll go with just the inductor. And then we start turning the capacitors. And it's a little tedious, but we can get it down to pretty much 1-to-1, 3.22, 1.87, 1.998. You gotta Okay, 1.79. I'm turning the output capacitor. Now I'm going to turn the input capacitor. You just got to go back and forth. This is tedious and boring. This is like watching grass grow. Then you go back to the inductor, and you keep tweaking this. I don't know if you really want to see all this. I guess I could stop the camera and just do it, and then show you what the results are. And now I'm turning the output capacitor 30. And now the input capacitor. Okay, now the inductor again. And I get it down to 19. Output. Sorry it takes so long, but this is kind of the way it works. Well, I'm kind of in a there we go. We're really getting it down there. We don't have to make it exactly 1.02. That's close enough, isn't it? Now we make all these measurements again. We go back up here to our spectrum analyzer. And let's get in real close to it. Okay, and we'll start all over at 14.254 frequency, 14.254 megahertz. And it said we're down minus 7.6. Minus 7.6 at 14.254. And then we go to 28.5. So actually, without the tuner in there, we're down at minus 6.5. Now we're down at minus 7.6. So we lost 1.1 dB. That's what I would call the insertion loss of our device, about 1 dB. Okay, and the SWR still set at 1.02. Okay, and then we measure 28.508 frequency. 28.508 megahertz peak. See, that's down at minus 56 point something. Minus 56 point. So it's actually doing its job. Minus 56.2, I guess. At 28.508. And the next one will be 42.762. 42.762 megahertz peak, and that's down at minus 25.3. Minus 25.3 and 42.762. Okay, I think you've seen enough of these measurements. I'm not going to go into another set, but I'll tell you why I did this. I'm going to take the camera off here. That you've seen exactly what we're up to. I found out, this is the way I've been doing it. I found out that I personally like to set these at half mesh and half mesh, so I had some play in each one. And then I would go through and I would do the inductor. I would turn the inductor until I got it as low as it would go, which ends up at about the same place, so I don't think it really matters. And then I start playing with the two capacitors again. I never even have to move the inductor again, and I can get it. It seems like I can get it down there a lot quicker. You know, just by kind of look at that. See, wasn't that a whole lot faster? Okay. Now, here's what we started. Here's the point of all of this. These are the numbers right here. This is the actual output of it without being into the tuner. And this is the output going through the tuner. So we had about a decibel of loss there, between the difference between 6.5 and 7.6. Second harmonic was down 43 dB. There's that 56 dB, so it does have. See, there's only 1 dB difference here in the output. So the fundamental frequency got through pretty quick. That much attenuation. But we do have some nice attenuation with the second harmonic, and this one's 16 dB and this one's 20, and some nice, like 9 dB extra there. If this were 26.6, it'd be 10 dB. See what I mean? And from 43 to 56, that's 13 dB on the second harmonic, and like 9 dB on the third harmonic. So the darn thing works. Now, the way that I did it, see, I put this ARRL. That's the way they suggested doing it. And if you do it my way, my little bit quicker way, the differences are not quite as good. They are insignificantly worse, if that makes sense. But their way is ever so slightly better. So I have to give them credit for that. I wasn't trying to prove them right or wrong. I just wanted to know what was the best way. I wanted to know if it actually made any difference. So their suggested method is this. Set this thing completely mashed. Set this one completely mashed. And then start with the inductor. And then you got to go round and round and round several times. If you start with them half mashed, and then you do the inductor, then it seems like you got to just go back and forth a little bit. I believe their method adds a little bit less inductance. I may be wrong with that, I don't remember. One way or the other. So there you go, ladies and gentlemen. I know it's a little dark there looking at that. I don't have any more lights in here. I got this one, but that might help a little bit. Probably all in the wrong place. But there's your antenna tuner. I always encourage people to build their own. When you build your own, you understand it better. And oftentimes when you build your own, you're making it out of parts that are much larger than the commercial ones that are going to be made just to do exactly what they say, or hopefully do exactly, at least as much as they say. How much power would this one handle with that small inductor? I don't know, 300 or 400 watts, I think, safely. It's not a kilowatt. Here's why I built it. I want this right here, what we're looking at, it's kind of cute, to replace this big honker over here. This is what I use right now to tune the input of this 833 amp. Because the input of this amplifier is fairly high impedance, and with a 2-inch chassis, I don't have enough room to build the tuner in there. So I had to use an outboard tuner, and this is one I built lots of years ago. You can see it's a little bit of overkill, like I say. It's got a much larger inductor in there and everything. And on my 40 meter band, I use this Collins 180 S1, if you can see that. I know it's a little dark in there. But that does a really good job of tuning the actual antenna that my AM transmitter is working into, which is the antenna just an inverted V. And up here with 2 switches, these 2 switches, this one right here isn't necessary, it's just part of hanging there. I could just make it go straight through. But one switches off, this selects the different rigs, whichever I got, my 833, my AM rig, the S-line stuff, the 3400Z, which is this little guy right here, or the KWM2A. This is the main output. These are the peak reading watt meter stuff. And this one right here selects either the 20 meter, 40 meter, or the dummy load. I've got 2 more open positions there, but I don't have any more antennas. Don't have any room for antennas. So there it is. That's my little station. And this little watt meter right here, actually, I made a video not too long ago about one with like 60 segments, but you know what? This one does a great job. It's just to let you know, when you glance over at it, I could sell these things, I believe. I'm not a very good salesman, but just to be able to glance over and see the lights blinking as they're supposed to be is reassuring. There's a lot of confidence in that. It has something a little bit added over an analog meter, in my opinion. But that is it, and I hope that it's worth something to you guys and ladies out there that like to build stuff. And I'm not pushing antenna tuners, but you know what? They do have their place. Stay safe, my friends.